Alright, here are a few things to consider after perusing the exams from this morning. Now, if we have a function that contains a logarithm, something like that. Now we're multiplying 3x squared by the natural log of x. We don't need to use logarithmic differentiation because we don't have a variable in an exponent. We can just take the derivative of this. We get f prime is going to equal the derivative of 3x squared is 6x, and we use leave the natural log of 4x alone, just straight product rule, plus 3x squared. Derivative of the natural log of 4x is 1 over 4x times the derivative of 4x, which is 4. If you really want, you can leave it like that, or you can rewrite it as 3x, because all kinds of stuff up here cancels out. Now, a case when you should use logarithmic differentiation would be if you had something like the tangent of x raised to the x power. Now you would want to take the natural log of each side because we've got that variable in the exponent, and the natural log of tangent of x raised to the x power is equal to x times the natural log of the tangent of x. That equals the natural log of y. Now if we take the derivative of each side, derivative of natural log of y is 1 over y prime. Product rule here again, x times the natural log of the tangent of x. Derivative of x is 1, that leaves us with the natural log of the tangent of x, plus we leave x alone. The derivative of the natural log of tangent of x is 1 over the tangent of x, times the derivative of tangent of x, which is secant squared. Now if we multiply each side by y, and let's remember that y is equal to the tangent of x raised to the x, we get y prime equals y, or the tangent of x raised to the x power times natural log of the tangent of x plus x times the secant squared of x over the tangent of x. And I would leave it just like that. Okay. Something else to consider is don't forget the chain rule. If we have something like natural log of 2x over 4x minus 7, take the derivative. Derivative of natural log is 1 over whatever's inside the natural log. Okay. Now we got to take the derivative of what's inside that natural log, or the 2x over 4x minus 7. Well, that's a quotient, so we got to use quotient rule, which is ho. D high, the derivative of 2x is 2, minus high. D ho, derivative of 4x minus 7 is 4, all over 4x minus 7 squared over ho ho. And if you want, you can leave it just like that. Now, there's a fair amount of canceling that can be done on this one, but if you want, you can leave it just like that. Let's see, what else should we take a look at? When doing integration, if you've got something like x squared over x cubed minus 3 dx, okay, when you look at this, or when I look at this, I see that the power of the denominator is 1 greater than the degree of the numerator. So that if I let u equal x cubed minus 3, that when I take the derivative, I get 3x squared dx. Okay, so that takes care of the x squared and the dx. And if I divide each side by 3, 1/3 du equals x squared dx. So now this integral becomes 1/3 the integral 1 over u du, which is 1/3 times the natural log of the absolute value of u plus c, and that equals 1/3 times the natural log of x cubed minus 3 plus c. Okay. So when you're thinking about picking a u, think about what you're going to get when you take the derivative of it, and how is that going to help in substituting out other parts of the integral. Now, let's see. Another example of something like that is if we have 1 minus e to the x, or how about 1 plus e to the x, raised to the 5th power times e to the x dx. Now if I look at this, I look inside the parentheses, because if that was just a single variable like an x, this wouldn't be bad, especially if I didn't have that e to the x there. But I know that when I take the derivative of 1 plus e to the x, I get e to the x dx. Well, what do you know? E to the x dx. So now, what I can do is I can rewrite this integral, u to the 5th du, which becomes 1/6 u to the 6th plus c, which becomes 1/6 times 1 plus e to the x to the 6th plus c. Okay? Not so bad there. Now, if you have e raised to a trig power, now look and see if they're multiplying by any other trig function. And ask yourself, is this a derivative of that? And well, you know what? It is. So if u equals the tangent of x du equals the secant squared of x dx. Well, secant of x dx. So this becomes the integral e to the u du, which is e to the u plus c, which is e to the tangent of x plus c. Okay? So that's not so bad. Oh, yes. Remember that if you have something like 5x plus 3e to the x dx, that sometimes it's easier to write these things as two integrals and deal with them that way. And down here, like, we get 5/2 x squared, and over here we get 3e to the x plus c. Right. Sometimes they're just easier to deal with if you can break them apart. Let's see. If you're trying to verify a derivative, take the original equation and take the derivative of it. And remember that if you have something like 1 over x plus 1 as a derivative, and they ask, does this thing have any vertical tangent lines? What you're looking for is where the denominator would equal 0. And here that would be x equals negative 1. I'm also going to tell you that you need to be careful, because remember that the natural log of 0 is undefined. Right? We can't take the natural log of 0 or a negative number. Okay, just positive values. Let's see. Anything else you should know? Hopefully that does it. If you have any other questions or want to see anything else, let me know. Otherwise, have a good weekend.